What I would like to do in this presentation is introduce a child with an orthopedic condition treated at the Shriners Hospital for Children in Lexington. I will walk you through the child's experience. What is their problem? How is that problem medically defined? How is treatment planned? How is treatment carried out? And what are the results? TG is a 15-year-old young man with cerebral palsy spastic diplegia. Cerebral palsy spastic diplegia is a problem within the brain which originates sometime within the first 2 years of life, resulting in damage to the motor section of the brain, that part that makes our muscles move, and result in contractures of muscles, shortening of muscles, and change in bone growth. Sometimes the children require crutches or walkers. Some are unable to walk at all. TG is a young man who is able to walk with his spastic diplegia. He had been followed for several years as an outpatient at the Shriners Hospital for Children in Lexington. At his regularly scheduled outpatient visit, he and his parents tell me that over the last 1 year, his walking has become more difficult, such that he now requires a wheelchair for any long distances and mainly stays at home and cannot participate in activities with his friends. When he tries to walk, he has severe knee pain that restricts his ability to walk any meaningful distance. He and his parents are increasingly frustrated with his declining abilities. On clinical examination, he demonstrates a crouched knee gait pattern and can only walk for a short distance before he must sit down. His physical examination primarily shows his hamstring muscles behind his legs are extremely short and tight. To properly document his walking ability and define what else might contribute to his bent knee walking pattern and develop a treatment plan, he is referred for an outpatient visit to the Shriners Hospital for Children Lexington Motion Analysis Laboratory. Many of you have toured the Motion Laboratory. For those of you who may not have had that opportunity, I will explain the laboratory to you as I did to TG and his parents. The Motion Laboratory is a place to study TG's walking ability in great detail. Just as the heart doctor does not listen to your heart only, but takes electrocardiograms, blood flow studies, and other complicated technical studies, the Motion Laboratory comprehensively details a child's walking ability. After a thorough physical examination by a physical therapist, accurately measuring all joint range of motions, muscle strength and control, wires are taped over the main muscles of the legs. These wires pick up the electrical signals of the muscles as they work when the child is walking. Small balls that reflect light are placed on the skin over the joints of the body. The child walks down a walkway over pressure-sensitive plates in the floor as 6 cameras around the walls record the walking. All the information goes into the computer, which produces a 3-dimensional model of the motion of all the joints and TG's walking. This video shows how TG looks as he walks. As you can see, he walks with his knees markedly bent on his toes and is barely able to walk to the chair and back. These are examples of kinematic motion data, that is, muscle activity, electromyographic data, and kinetic, that is, energy and power data generated by the software. The information from the physical examination, kinetic, electromyographic, and kinetic data clearly demonstrated that the short, tight hamstring muscles, quadriceps front thigh muscles, and gastrocnemius or calf muscles were primarily responsible for his walking problem. This combination of short, overactive muscles was causing him to walk with a crouched, stiff knee, toe-toe walking pattern and limiting his walking ability. We recorded a good walking speed, which suggested that he would have a good outcome with correction of these short, contracted muscles. The recommendation by the Motion Lab team, that is a physical therapist, engineer, and surgeon, was for a surgical lengthening of the hamstring muscles, calf muscles, and a transfer of one of the front thigh muscles, the rectus femoris muscle, on both legs. The surgery was to be followed by intensive physical therapy for 5 days, discharge home with a home program, and readmission to the hospital in 3 weeks for further intensive therapy for stretching, strengthening, and training.